Hello and welcome back to Precalculus1. We are starting our chapter 7. We only have 3 sections to worry about in this last chapter. And we're going to talk about sections 1 and 2 today. Actually, section 1 is not in the curriculum. Repeat or review of what you guys learned in basic algebra course. Basic algebra course teaches you systems of 2 equations and 2 unknown, right? And the goal of this particular section is to learn the 3x3. So we are going to learn a 3x3 system today, focus mostly on that, but I do want to mention 2x2 because that method is important because it is the part of what you guys have to do. So let's take a look at this. Just had to make sure that the sound was working because I switched the microphone in middle of talking. All right. So let's start with just a 7.1 2 equations, and that's a review from algebra. So no new material here whatsoever, as just what we have. Now I'm going to review this by picking one equation and running through all 3 methods you guys possibly learned back in algebra. So here we have, let's say, x plus 3y equals to 8. And 2x minus y equals to 9. So this is what we call a system of 2 equations with 2 unknown values. So those are given to us, and we have 3 methods: graphing, and then substitution, and addition, also known as elimination. So these are the 3 methods that we have. And then we have solution, which can be one solution when you get just xy. You can have no solution, or you have infinitely many. They all manifest over here. You get a equals to or a doesn't equal to b. Over here you get a equals b. So we'll see these as we go through examples here and there. All right. So number 1, graphing method. People generally avoid that one because we are not really precise with our graphs, and we have to be very precise with our graphs in order for this to work out. So the graphing method would give us the intersection, and if it gives us the intersection x and y, well, that's the solution. X is equal to a number and y is equal to a number, right? In general, as I said, we don't use that method because you have to be very precise. You have to have square paper, you have to have instruments to draw, and then if you run into fractions, you have to be very picky on how to graph those and so on. So graphing method could be, counterproductive, I would say. But the other 2 methods are the ones that we actually focus on. So, for instance, substitution method, right? So you take one of these equations and you solve it for a or b. X or y. So from here, x is equal to 8 minus 3y. and now you plug that in. So you have 2 times 8 minus 3y minus y equals to 9. That gives us 16 minus 6y minus y equals to 9. And now you have 16 minus 7y equals to 9. So this is 16 minus 9 equals 7y when you swap the sides. And you get 7y equals to 7, y is 1. And since you have the equation that x is equal to 8 minus 3 times y, which is 1, you get 8 minus 3, which is 5. And we have 5, 1 as our solution. So this is something you learned in algebra. And we are going to use this because every 3x3 system, or 4x4 and 5x5, which is what we are concerned with in pre-calc, eventually reduces to 2x2 case that you have to solve. And once you have a 2x2 case, then you solve it using one of these methods. Now let's do the same problem using elimination. So what is my problem here? X plus 3y equals 8. And 2x minus y equals to 9. To review elimination, what we do is we pick a variable that we want to eliminate, whether it's x or a y, and then we multiply one or both equations with appropriate numbers so that we get additive inverses. Additive inverse is the number, positive and negative number, so let's say positive 2 and negative 2. So that's a positive and negative number which add to 0. That's why they're called positive. That's why it's called additive inverses. So our job is to make sure that the signs are opposite and that the value is the same, and then when we add them, it will add to 0. So we already have positive and negative sign on y, so we're just going to multiply bottom equation by 3. Right, that's it. Because it will create a negative 3y, and then you have 3y minus 3y, and it's going to give a 0. And then we're good to go. So, and here's another thing, guys. When we start working on 3x3, it's going to be more equations, obviously, and it's going to be more confusion if you write all over the place. It is very important to keep copying everything in every step, even if you didn't use it, so that you can visually immediately know what to do in the next step. People that have no visual orientation, then they're slappy notes and write in all possible directions everywhere, generally have a very difficult time with this. But if you're organized, this is a joke. You see, every time when I write the system, I always write 2 equations. And every time I underline with this line to give the new, so I will always have equation 1, equation 2, equation 1, equation 2, equation 1, equation 2. I will keep having this, and later I'll have 1, 2, 3, 1, 2, 3, 1, 2, 3. If you are organized like that, you will not lose equations. You will not, waste time scanning where the stuff is. You invest extra 3 seconds to write the equation, and then it's very quick to refer, and it's also quick to see what the next step is. So when I look at the system here, I'm not doing anything to the first equation, so I just copy that. The second equation gets multiplied by 3, so that becomes 6x minus 3y equals to 27. See, I still copied the first equation, even though I have no change in it. Nothing changed. Because now when I have the two equations together, I see the additive inverse here. So I know that my next step is to add two equations. Now, when I add two equations, I'm not going to have two equations anymore, because now x plus 6x is 7x. These guys cancel, equals 2, 8 plus, this is 35. And from here we see that x is 5. So it's very structured, but only if you write everything down, and you can always see what the next thing is. And now we just need to find y. And you can do that in any equation on the screen. Whatever, doesn't matter. So maybe you can pick from the second equation, 2x minus y equals 9. That's 2 times 5 minus y equals 9. That's 10 minus y equals 9. And y equals to 1, because 10 minus 1 is 9, right? And there's your same solution, obviously, as before, because you can't get a different solution using a different method. In mathematics, there is only one solution, right? Correct? And then everything else is wrong. So this is what we mean by two equations, two unknowns. And whatever you learned before in algebra stays completely unchanged. And we are not going to bother with graphical solution here, because it's really picky, right, in this case. We are interested in 7.2, which is systems of three systems of linear equations in three variables. Systems of linear equations in three variables. This is used a lot later on. Those of you going to heavier math, you are going to see a lot of systems. There are 2 by 2 and 3 by 3. Sometimes you have 4s and 5s and 7s and so on. One of my differential equation students just complained about 4 by 4 system that he ran into. So solving these systems is going to be done by elimination method. So no more substitution, right? So now we're just going to have elimination method for these. You can use substitution. It just gets to be a little bit annoying with algebra and too clunky. So we stick to elimination only because we can quickly eliminate variables rather than using substitution and making expressions longer and having to do more algebra and all of that stuff. So we'll just stick with elimination. Now, as in the previous case, the only thing that you are going to do here is to multiply equations and then add. You can also subtract equations. So add them or subtract to eliminate one of the variables. So let's start with x plus y plus z equals to 4. X minus 2y minus z equals to 1. And 2x minus y minus 2z equals to negative 1. And as I said, I always underline because easy. Life is easy that way. Now, you are allowed to pick any variable that you want to eliminate here. You can eliminate x, you can eliminate y, you can eliminate z. So whatever. And you can pick which equation you want to multiply. You can multiply all of them, right? So let's eliminate z, for instance. We can eliminate z. We can eliminate x, we can eliminate y. It's very easy now because just by multiplying by 2, right, you can create everywhere 2x, or you can create everywhere 2y, or create everywhere 2z. So your job is to create positive and negative, and then just add those into a 0 later on. So say you want to eliminate z. How do you eliminate z? Well, if you add the first and the second equation, oh, I see the chat says let's eliminate x. Fine, eliminate x. I'm switching. Eliminate x. So what do I do to eliminate x? Well, there are a couple of ways that I can eliminate x. I can subtract the top two equations and come up with the equation without x. Right? So that's one of the ways. And that will eliminate x, and I will have one equation that will only have y and z. Then I can pick one of the equations, and then with this one on the bottom, with the third equation, multiply top by -2, and then kill x. It's important that in the first calculation you eliminate the same variable from two pairs of equations. So you can multiply by, let's say, multiply by -2, multiply by -2. So what would that give us? -2 plus, minus, -2x minus 2y minus 2z equals to -8. Second equation multiplied by -2 gives us -2x plus 4y plus 2z equals -2. And the third equation I'm not changing because I have a positive 2x there. So I'm copying equation as is. So as you can see, I multiplied two equations to create -2x. So I can counter that with the 2x down there in the third equation. And the third equation stayed unchanged. So I just copied the whole thing. And even though I never changed anything in the third equation, I still copied it. Now what happens? When I combine first and third equation, I will get the blue equation. So when I add those two equations, what do I get? -2x plus 2x is 0. -2y minus y is -3y. -2z minus 2z is -4z. And -8 plus -1 is -9. So when I add these equations, we have x cancel, -2 minus 1 is -3y, and then -2 minus 2 is -4z, and then -8 minus 1 is -9. The next pair is going to be second and third equation, and that's going to be orange. I'm not sure what the 2y is for. When you multiply y by a -2, you get -2y. And then when you add -2y plus a y, you get -3y. So there is no positive 2y anywhere. So now, when I add second and third equation, x's are gone. We have a 3y plus z equals to -3. And look what you have now. Two equations, two unknown. And in this case, How lucky are we, huh? These guys are already set up for elimination, so by simply adding these two, I'm getting negative 3z is equal to negative 12 when I add equations. So y is cancelled, minus 4 plus 1 is minus 3, good, and then 3, negative 9 and negative 3, that makes it more negative, so negative 12. Z is 4. So now that I know that z is 4, I can go back into, let's say, orange equation and calculate y. 3y plus 4 equals to negative 3. 3y is equal to negative 7. Y is equal to negative 7 over 3. And finally, we plug all of these. I don't like this fraction. Let me just see if I copy the whole thing. X plus y plus z equals to 4. X minus 2y minus z equals to 1. And then 2x minus y minus 2z equals to negative 1. When I multiply top equation by negative 2, I get negative 2x, negative 2y, negative 2z, negative 8. And then I have negative 2x plus 4y, because times 2, plus 2z, and then minus 2. And then 2x, y, 2z, negative 2z, negative 1. Now, blue equation, when I add, these are gone. Minus 2y minus y is minus 3y, and then minus 4z, and then I have negative 9. And then the orange equation, 3y plus see? That's wrong. When I, not there. When I add this, I get 0z. So this is supposed to be a 0 here. Alright, so that changes obviously everything, because we calculated y instantly. So y is negative 1. So now plug in. How did you cancel out x? When I add them, that's why I multiplied by negative 2. Negative 2 plus 2 is 0. That's why there are no x's here. We create additive inverses so they add to 0, and that's how we cancel the variable. And you can do that for any of these variables. I worked with x. I wanted to originally do with z, but then I think Paul requested x, so fine, we'll eliminate x. We can eliminate any. So now I have negative 3 times negative 1 minus 4z equals to negative 9. To calculate z, that's 3 minus 4z equals to negative 9. Negative 4z equals to negative 12. Z equals to 3. And finally, we can bring that to x plus y plus z equals to what? 4. Equals to 4. So what do I have? X is unknown, y is negative 1, z is positive 3. So when you plug them in, this is x plus 2 equals to 4, from where x is 2. So now you have the ordered triplet. 2, comma, y is negative 1, comma, 3, which is the z. By the way, what you are looking here at is that the equations of the plane, and they intersect and they create corners and things like that. So all of this later on in math, right, will get its purpose. If right now it's computationally too complicated to solve those types of problems, we just solve the systems. But eventually in Calc 3 you are going to do this like in a margin and then actually do the Calc 3 problem. Let's take a look at another system. So there's nothing to learn other than, be careful, make sure you are multiplying by appropriate value to get additive inverses so you can cancel them to 0. And if you're canceling a variable, make sure you're canceling the same variable in the other pair. Let's take a look at another system here. It doesn't really matter, they're all... Well, there are some that are more annoying than others, so... 4x minus y plus 2z is equal to 11. X plus 2y minus z equals negative 1. And 2x plus 2y minus 3z equals negative 1. Now, for the experienced eye, in this case me, it is obvious that we should eliminate y's, because you only need to multiply first equation by 2 and then add first and second and then first and third equation, and that will kill y's. So try that. I'll give you a few minutes. Try to multiply top equation by 2 and then add 1 plus 2 and 1 plus 3, which would kill y's. And then you will have a 2 by 2 system with x and a z. Figure out x and a z and then go back, figure out y. Let's see. let's take a look. So when we multiply top equation by 2, we are going to have 8x minus 2y 11z plus 0z. Yeah, that's 11z equals 22, z equals 2, which should be good. So 8x minus 2y plus 4z equals 22. And the other two equations I am not changing, so I will copy them as is. Now I'm going to use my color trick. I will add equations 1 and 2 because, see, they create a 0 on y. And the blue equation works out to be 9x plus 3z equals to 21 when I add. So that's a 9x, that's a 0, that's a 3z, and that's 21. Now we add first and the third equation. We'll use orange. So that's 10x when I add these two. These guys cancel because it's positive and negative. That's why we multiplied. And then that's 1z. You can just write z. And then I have 21 on the other side. And now I have a 2 by 2 system to deal with, and we know how to deal with 2 by 2 systems, right? Whatever magic you can pull. Now, the fastest way obviously is to multiply bottom by -3. That will kill z's, because the other way you would have to multiply top by -10 and the bottom by 9 and create 90s and so on. If you can multiply only one equation, right, you're looking to only deal with smaller numbers. So multiply by whatever. We're going to do multiply -3 and kill z's. So top equation doesn't change, so I'm going to copy that the way it is. And then the bottom equation is -30x, -3z, and -63. So now when I add these two equations for our elimination method, I get -21x, z's are gone, and I get -42, from where x is clearly 2. And if x is equal to 2, right, we can go back to any of the equations, blue or orange, to calculate z. Now obviously orange equation is better because it already has a single z. So that's 10 times 2 plus z equals to 21. That's 20 plus z equals 21, and z equals 1, obviously, right, because 20 plus 1 is 21. Now that I have x and z, I go back to any of the original equations that has the y in them to calculate. So we can use the first equation, which is 4x minus y plus 2z equals to 11. And in that equation, I'm going to plug in what? X is equal to 2 minus y plus 2 times z is 1. 8 minus y plus 2 equals to 11. That's 10 minus y equals to 11, from where y is -1. So my solution set is x is 2, y is -1, z is +1. You always list your solution as x, y, z. That's a 3D point of intersection of three planes. You will learn that in Calc 3. So technically what you're doing now is you are intersecting three planes and getting the intersection of the three planes. And when they intersect this way, they are, right, it's a corner of some kind. Like where you have the three walls, well, I mean 2 walls and a ceiling, let's say, meet at that corner. So each one of those is a plane, and then they intersect as a point. But then 2 opposite walls are parallel, they never intersect, so there's no solution, and so on. So there is a lot of cool stuff that you can learn later. Now we're learning just the mechanics. It's boring, obviously, just grind. We don't put any context to it, it's just a grind. But later on in Calc 3 it becomes much more interesting, obviously. And you may run into problems that already are missing a variable. And those problems are awesome. Because you have less work, right? You had to work with 2 pairs over here of equations to eliminate. But remember, if you already have one of the variables missing, then you just have to do one addition and you're already down to 2x2 system. So anytime when you see a problem that was already missing some stuff, those are generally way faster and nicer. So here is a 2x, this is problem 13. 2x plus y is equal to 2, and there is no z. X plus y minus z is equal to 4. And 3x plus 2y plus z is equal to 0. I don't know if you can get easier system in 3x3 realm. Because look at it. I don't even have to multiply these equations. If I just add them, they will kill z right away. So for my 2x2 system, I already have 2x plus y is 2. And now, these two will give me another equation. When I add them, I get 4x plus 3y equal to 4. That's when I add. And now, if we multiply top by -3, it will kill y's. If you multiply by -2, it will kill x's. It doesn't matter which one. Remember to copy the equation that you multiplied and then copy the equation you didn't use, because they're still in the game. And now when you add, the y will die. This is -2x equals to -2, x equals 1. So if x is equal to 1 and 2x plus y equals to 2, that means 2 plus y equals to 2, then y is obviously 0. Because 2 plus 0 is 2. I mean, you can go ahead and subtract 2 on both sides if you want to, but also it's fun and fast to just say, oh, what do I need to add or subtract, right, depending on what the problem says. What do I need to add or subtract here in order to get the answer I want on the other side? And that's clearly 0. And now we want to calculate z. You can calculate z in any of the equations. X plus y minus z equals to 4, second equation. Obviously, you can't use the first equation because it doesn't have a z in it. And you're looking to calculate z. So common sense, right, kicks in and says, yeah, use either equation 2 or 3. Now, equation 2 has less calculations because you don't have to multiply by constants, right? So I can just plug in that x is 1, that y is 0, and z we're looking for equals to 4. So negative z is equal to 3, z is equal to negative 3. And now all I need to do is to write my solution. 1, 0, negative 3. So x is 1, y is 0, and the z is negative 3. So these 3x3 systems will be back big time later on in math. Make sure you understand these and know how to do this. Let's take a look at one more system because we can, and that will be it. It's not very exciting. When we do 7-4, that will be exciting because we get to solve equations between linear and nonlinear when they intersect or not intersect and stuff like that. So that's going to be much cooler than this. Now, if you know the procedure, these problems are easy. Can we make these problems hard? The answer is no, we cannot. Can we make these problems annoying? Yes. Yes. 3, 2x plus y plus 5z equals to negative 1. 2x minus 3y plus 4z equals negative 9. And finally 4, 1 plus x is equal to negative 3 z minus 3y. So this is annoying, right? Because now you have to distribute and shovel terms left and right just to get it in the form where you can start thinking about multiplying things. Not hard, right? It's annoying. It's annoying. So you have to, go through these, one by one now. So where do we begin? Well, distribute everything and make sure you put them x, y, z, equal a number. So we have 6x plus 3y plus 5z equals to negative 1. I think this is a problem 17 in your textbook. So 2x plus y plus 5z equals negative 1. 2x minus 3y plus 4z equals negative 9. 4, 1 plus x equals to 3z minus 3y. Good. Next one. 2x minus 6y plus 8z equals to negative 9. See, this 2 does not distribute on a negative 9. But when you are multiplying like this, then it goes to everywhere, including negative 9. So be very careful about these things. And what do I have on the bottom? I have 4 plus 4x is equal to negative 3z plus 9y. And we need to clean up the bottom equation. So let's copy everything and have it nice and clean. So 6x plus 3y plus 5z equals negative 1. 2x minus 6y plus 8z equals negative 9. 4x stays on the left side. Minus 9y has to move, so changes the sign. Plus 3z also has to move, changes the sign. And 4 has to move to the other side, changes the sign. Ta-da! So now you can work out which variable to remove. So my hope is that you are not thinking about removing variables y and z because they have 8 and 9. X has 2, 4, and 6. So let's see what you're going to get. So try this one on your own. I pretty much told you which variable you are supposed to have. I mean, you can have any. But just for the ease of calculation, you should always use the one of the formulas. How about that? I don't want to tell you. But try it on your own. Keep going. Keep going. So it should be obvious that we are eliminating x. And you can do it in stages. You see, you can find, like a common denominator, right? You can find the common value, in this case would be 12, and then multiply all three equations to match and make it positive and negative 12, and you're good to go. So that's one way. The other way is to say, 2 can work with both of these. So on my first run, I am going to multiply this by -3 and kill it with a 6 up there. And then in my second run, I'm going to multiply it with -2. So when I do this, I will add here. And when I do this, I will add here. So I'm using the second equation twice. I could have done that with y's as well, because I could have multiplied the top equation by 2 and eliminate with the second, and then multiply top equation by 3 and eliminate with the third. That might be even better solution, but such is life. So the blue, I have 6x plus 3y plus 5z equals -1, and the bottom equation multiplied by -3 gives me -6x, positive 18y, -24z equals -27. And when I add them, x's die, so I just have 21y minus 19z equals to -28. 21y, -19z, let's call that good. And now, for the second run, I'm going to take equation 2 again, but this time multiplied by -2, and I will get -4x Oh my tablet is getting overheated, so it just now flies all over the place. Alright, so second equation times 2, negative 2, and then copy the third equation. So negative 4x plus 12y minus 16z equals to negative 18. So I distributed negative 2 to all four terms. Got negative 4x and positive 12y and negative 16z and then negative 18. And good. And now copy the second equation, which is 4x minus 9y plus 3z equals negative 4. When you add those, x's drop again. We have 3y minus 13z equals to negative 22. And if you observe, right, we have two equations, two unknown. So 21y minus 19z equals to negative 28. And we also have 3y minus 13z equals negative 22. Bottom equation times negative 7. That should be clear. Because 3 times 7 is 21. And we need opposite sign, so we're going to multiply it by a negative 7. And that will align us up to kill the y's. So 21y minus 19z equals to negative 28. I am not touching that equation, so I just copy it. And now I get negative 21y plus this is 91z equals to what is this, 154? I hope. 7 times 2 is a 14 and a 14 offset, yeah. So the y's drop and I have 91 minus 19. That's 78. Z is equal to 154 minus 28. The way you subtract this quickly is you add 2 to both numbers, so 156 minus 30. And that's 126. Apparently I can't subtract here. That's 91 minus 19. That's a 2. That's a 7. 72. Apparently I can't subtract. It's a indication that I should end my day. Something else is wrong. There is a mistake somewhere, because I know that the solution is supposed to be z equals 1. This is not going to give me z equals 1. First, let's see if we copied the problem correctly. 3, 2x plus y plus 5z equals minus 1. 2x minus 3y plus 4z equals negative 9. 4, 1 plus x equals negative 3z minus 3y. Good. So problem is copied It says negative 18. Not sure what's negative 18. But it's wrong anyway. So now that's a 3 and then, no, 6 x 3y 5z negative 1 2x minus 6y plus 8 equals negative 9. That's a 4 and then negative 3z plus 9y. Now we copy the first equation as is, copy the second equation as is. See this? There we go. Give me a second, I'm crying. They gotta fix everything now. I can't copy numbers. What hope is there for me to do anything more than that? So that's a negative 9 right there. So that's going to give us positive 27 here. And when I do this, 27 minus 1 is 26. And that's going to be my 26 over here. And that's going to be my 26 here. And it's still wrong. Back to see what else is wrong. And then that's 4x Yep, at this point I am about to cry. It is very difficult to find mistakes in these. It's always better to start from scratch and then be more careful than try and find a mistake. So I'm just going to, the other problem equals positive 18. Negative 9 times 2 is positive 18 over here. And now 18 minus 4 is 14 over here. I have no clue whether that helps. So now I have 14 times negative 7, that's 70, and 28, negative 98. Yes! That gives us negative 72. Well, thank you. Without all of you guys, I would definitely not pass this class. So z is negative 1 finally. Kill me now. Z is negative 1. So now that I have z, I can go into any of these equations, and all of them are mess, to calculate y. Maybe this one has the smallest numbers. 3y minus 13 times negative 1 equals to 14. 3y is equal to 14 minus 13. 3y equals 1. Y equals 1/3. And now I have all of these. Go calculate x. Let's pick an equation for x. So these are the best equations here. And just pick your poison. And they all look bad. So 6x plus 3y. Six x plus 3y plus 5z equals minus 1. Six x 3y plus, they're all positives, right? 6, 3, 5, negative 1. 6, 3, 5, negative 1. Great. Plug in values we have. So we have 6x plus 3 times 1/3. Well, that's nice. Plus 5 times negative 1. That's nice. Negative 1. So 6x plus 1 minus 5 equals negative 1. That's a 6x. This is minus 4. And then goes to the other side, is plus 4, so 3. X is 1/2. Well, 3 over 6, which is 1/2. So the solution is 1/2, 1/3, negative 1. And book has the same answer. Yes! Got it. So this stuff is on exam, reserved for the final, obviously. And we'll see, what we're going to. I'm going to post announcements with options regarding final and grades and everything, so you guys know exactly what's going on. The quizzes, I hope, started already. I hope. I don't know. Yes, exam 3 quiz 1 is on today. Closes at midnight, so you have another 4 hours and 40 blah minutes. So less than 5 hours left. The quizzes started today, 29th. The first one closes at midnight. First quiz is on. It's been on all day. Started at 6 a.m. You said quizzes started on Thursday. Did I? Or maybe I have my... Why is it showing on my screen? It says E3 quiz 1 429. Well, apparently I'm wrong. Oh, I'm looking at the MyMATLAB for differential equations. Woohoo! Oh my god! Guys, I have no clue where I am. It's, yeah. Yep. Quiz 1 tomorrow, 6 a.m. Well, good thing some of you are okay. So quiz 1 tomorrow, bright and early. Every day there will be a quiz, and I will post in announcements. So what did we do for the test? I'm just having trouble keeping track of all of this. I think here, oh yes. So we said exam 3 5759. Do I have the same on my sheet over here? No, I don't. I have to fix this. So 5759. I have a wrong date on my. So 57259, and then the final exam 510 through 512. So as soon as this one closes, the next one opens. Perfect. Okay. I am going to double check the homework and everything else. Make sure that it's open, and please read the announcements. We don't have the project this year. The labs are, I told you, they're condensed into a single thing that you guys are supposed to submit the day of the final. That's going to be also the final review at the same time, so it's like a double purpose. I'm going to post everything in announcements so you guys know exactly there is no project this in the semester because of the situation. So yeah. For the final, well, see that this is the problem. If it takes very long time to grade these online things if I'm doing the partial credit. So I can't answer the question if it's going to be graded by the final or not. That's, because the final is literally the next day. So what I can do is I can create the exam so it's multiple choice. There's no partial credit. So if you score 12, you score 12. Because there's no partial credit, but you will have your grade immediately. And then Now, the rule of the department is, if you take the final, it must count, and there is no, I've scored a bad grade on the final, I don't want it. So you are either taking the final and counted whatever the grade is, or you are not taking the final at all, and obviously the average of the 3 exams will replace it. There is no going back on the decision later on. So you will have to make that choice, and it's very simple. You don't have to inform me. If the final is not attempted at all, then the exam grades are calculated as the average, as the final. If there is an attempt on the final exam, and even if it's a 0 or a 3 or a 99, it's counted in the average. So you are either going to calculate, so you are not allowed to abandon the final and say, I don't want to count it. You are not allowed to sample it. So you are either taking the final or not. And the final is the same thing like the regular final. It's going to be 2 hours, and it covers all the chapters. So we have chapters 1, 2, 3, and 7. And it is going to be whatever the amount of problems is appropriate for 2 hours. Being that, we do have the average times for what the students should take to solve this, 15, 16 questions, something like that. So, there you go. I'm trying to see if your homework is open over here for chapter 7. It appears that it is not. I'm going to open even what we didn't cover, so don't panic. It will stay open all the way through the final for chapter 7. So don't email me about it. Just once we cover 7.4, you go and you do the homework. You don't have to do 7-4 tonight. I just need to make sure. So 7-1 is not in a curriculum, so I can't open 7-1. So 7-2, 7-4. I am going to open also 7-3 optional section because you might want to practice this. Let's say you might go to Calculus 2. If I have at least 10 minutes, I will give him something. 7-3 will not be on the final, but I will talk about it anyway. Okay, so open this. And the course ends on the 12th, so 12th is when the homework closes. So you should be able to see your homework 7-2, 7-4, and then it should say 7-3 optional. So that's the homework. I am going to, one more time, check your exam 3 quiz 430, 5-1, 5-2, 5-3, 5-4, 5-5, 5-6. Excellent. All right, you are all set with this. I am going to post the syllabus and options and all of these things in Canvas, so please look for that. I just have a lot of things that I'm doing at the same time, so I'll post that very soon. And then office hours, I'll have office hours tomorrow. I'll have office hours next week, so keep contact me, ask if standard stuff. So all right, guys. I will see you tomorrow. I think my office hours are 5 o'clock, I think. I do have a class at 3. I have my algebra. Yeah, I have my algebra at 3. Then I'm going to, after the class, I'm going to eat, and then I'll be on at 5 tomorrow for office hours on Teams. And then I will have my other class, Calculus, at 6. So if you have any questions, and then I'll have my office hours next week. I'll probably have extended office hours. And yes, quizzes are starting tomorrow. Quizzes are starting tomorrow. I just double checked that. So you have quizzes, and homework for chapter 7 is open. Homework for chapter 3 is still open. So keep working on those things, and I will talk to you soon. Bye.